There are many applications we can use rational expressions in. One of the main ones is when we look at the distance, time, velocity relationship. And some of you may have seen this in your science classes. Now there are three relationships we can write. When we look at this triangle, we can say that the velocity times time is equal to the distance. That's one relationship. We could also say that the distance divided by velocity equals time. So notice that the d is on top. And we get time is equal to distance over velocity. We could also say that distance divided by time is velocity, so we get this expression here. So these two expressions are going to give us rational expressions. Okay, so we can, many of our rational expression problems can be modeled, or sort of many of our distance, time, velocity problems can be modeled with a rational expression. Now it doesn't have to be, sometimes it is this expression here. Okay, so let's take a look at how we can generate rational expressions using this relationship. So it says here we have a distance of 200 kilometers and the time is x plus 3 hours. To write the expression for velocity, we say that the velocity is equal to the displacement over time. Really, we should say displacement instead of distance. And so that's going to end up being 200 kilometers over x plus 3 hours. And this expression represents velocity. We can also say that here we want to write an expression for time. So we've given the velocity in this case. Velocity is x plus 20 kilometers per hour, and our displacement is 300 kilometers. So our velocity then, our time expression, the time is equal to the displacement of 300 kilometers divided by x plus 20 kilometers. So the kilometers will cancel out, and kilometers per hour, since hours is in the denominator of the denominator, it's just going to be, this is going to represent hours. Okay, so that would be the units of that expression. So let's take a look at some other problems here. So anytime we have a rate, we can think of a rational expression, using a rational expression, because rates are a comparison of some quantity to another quantity in a ratio. It says here, every member of a soccer team contributes money to buy equipment for the team. The total cost is $3,000 and there are 17 members on the team. So what is the cost per person? Okay, the cost per person is going to be cost compared to people. And so the cost per person in this case is going to be a $3,000 total cost over 17 members on the team. So when we work this out, we can write this as, we can leave that as a ratio like this, or we can actually divide this to make it a unit rate. So 3,000 divided by 17, we can say is $176.74 per one person. Okay. So if X more people join the team, what's the expression for the cost per person? Well, our cost per person is not going to be $17.47. In fact, we can't calculate the number of the actual value that we're going to, the cost for each person, because we don't know the number of people. So we need to write this as a rational expression. So the cost per person is going to be the total $3,000 divided by the 17 people that were originally there, and we're going to add X more people. So this is now my new expression for the cost per person. So here we can come up with some relationship. It says how many additional people, so we're looking for that X, that's the additional people, to the original 17 do you need for the cost per person to be less than $120 each. Okay, so we're going to write this expression, the cost per person, 3,000 over 17 plus X. That needs to be less than $120 per person. So now we have an inequality that we can solve. So we end up with 3,000 is equal to 120 times 17 is going to give us 2,040 plus 120x. Okay, I shouldn't write this as an equal, I should keep it as an inequality, but we solve it just like equals. So we end up with 3,000 minus 2040 is going to give us $960. And we have 120x. Okay, these units, I'm just going to take out because these units are not necessarily correct. And then we're going to divide both sides by 120. So 960 divided by 120, we end up with 8. So X has to be greater than 8 people. So if we want the cost per person to be less than $120, then we need to have more than 8 people join the team.